All right, this lecture concludes lab exercise 8. It'll be on activity 5. We'll be looking at types of, characteristics, and elevation of different clouds. And we'll be looking at what happens when air is stable or unstable. So let's start off with what we know. We know and have studied that as air rises, it cools due to expansion of the parcel of air. Expansion results due to less air pressure acting on the parcel of air itself. As we move up in altitude or elevation, we have less pressure. We're decreasing in pressure here. So our value on my x-axis is decreasing. The total heat is spread over a larger volume. Thus a cooling effect takes place, but there's no heat that's being lost. It's simply spread over a larger volume, like the 3 dimensions that we've talked about. So as the parcel of air rises, it continues cooling and expanding until the parcel reaches its dew point. At this point, it is at its capacity or saturation limit, so it cannot hold any further water vapor. If the air continues to rise, it cools. It continues to cool and condenses out any liquid as precipitation, and we see this here. So the dew point. The dew point becomes very significant here. The temperature, this is the temperature to which a parcel of air would need to be cooled to reach its saturation. So once we begin cooling it below the dew point, this causes condensation. So the water vapor requires a surface to condense on, and this is what we're going to call a condensation nuclei. And these can be dust or aerosols. And the condensation nuclei are tiny, 0.0002 millimeters. But you have to have these aerosols, these dust particulates, and they're found naturally in the atmosphere. And these are where the water vapor condenses around, forming these tiny cloud droplets of 0.02 millimeters. But then they continue to grow and build into larger droplets. And this is where we understand this picture here, that the small raindrops grow as they converge with other small raindrops at elevation. This is called collision coalescence. That warm clouds create small raindrops that collide with one another as they grow until they're too heavy for the suspension within the cloud. So rain is cold because it comes from these high altitudes. So we get these small droplets that continue growing and building as they coalesce with other small drops, and they eventually reach a certain critical limit. In this case, a typical raindrop is about 2 millimeters. So the Bergeron process is where clouds below freezing have ice crystals that collect water vapor and fall as snow or melt while falling. Here's the key idea you need to take from this, that the air temperature in which the precipitation falls into largely influences what type of precipitation that occurs. So you can have ice droplets way up in the clouds, but as they fall through the atmosphere, they can actually warm up if the atmosphere is above freezing, and they can actually form rain droplets as they fall. So now let's look at stable or unstable air. We're going to talk about ELR, environmental lapse rate, and the adiabatic lapse rate. We've established a dry rate of 10 degrees C per 1,000 meters and a wet rate of 5 degrees C per 1,000. That stable air, the ALR, cooling exceeds the ELR. Air is not rising. And unstable is saying that the environmental lapse rate cooling exceeds the adiabatic lapse rate. Air is rising. If air is rising, it's generally termed unstable. So absolute stability, when rising air, or air that's kind of at a location, is cooler than the environment, that clouds can actually just stabilize themselves if they are cooler than the surrounding environment. That the ELR and ALR differ. The air forming the cloud is cooler than the surrounding environment, so it's considered stable. And these clouds have next to zero chance for severe weather. But absolute instability, things change. The parcel of air that's rising acts like a hot air balloon. That the rising air is warmer, less dense, more buoyant than the surrounding air. So it continues to rise. You'll notice that the temperature is warmer than the surrounding air. So the environmental lapse rate and the actual air temperature of the parcel of air, they are unstable. It's going to continue to rise. It's going to continue to cool. And this is the features that gives us dramatic potential for severe weather. So now we can start looking at clouds. A cirrus cloud is considered a curl of air. Clouds are high, white, and thin. They can occur in patches or as delicate veil-like sheets or extended wispy fibers that have a feathery appearance. Stratus clouds, very common. Clouds that are best described as sheets or layers that cover the whole sky. While there may be breaks, there are no distinct individual clouds, that they all kind of like run into one another. And cumulus, these are a pile of clouds that consist of globular individual cloud masses. They normally have or exhibit a flat base and have an appearance of rising domes or towers. They can be considered cauliflower-like or cotton ball-looking in appearance. So there's 3 different elevations that we'll look at. We'll look at upper-level clouds, middle-level clouds, and low-level clouds. Your upper-level clouds are going to be your cirrus your cirrocumulus. You can even throw in cirrostratus in there. We can talk about your middle level clouds. This ranges, upper are going to be 20,000 feet plus. Your middle level are going to be 6,500 to 20,000 feet. Your altostratus and your altocumulus. And lastly, your low level clouds. These are below 6,500 feet. Your stratocumulus, your stratus, and your nimbostratus. It's not labeled here, but this would be a rain cloud. Then you have vertical development clouds, and this is the key here. You're going to get used to hearing the term cumulonimbus because this is the type of cloud that's associated. These very, very large, they can create this anvil shape, they can create like a mushroom cloud type. They've just grown to very, very high elevations or altitudes. And the cumulonimbus are what we are going to be looking at when we study severe weather. Because this air rises and it's unstable air, it can have thunderstorms, you can have lightning, you can have severe winds. As air rises, it eventually cools and you get downdrafts for tremendous amounts of wind. You can get hail, you can get very heavy rain, you can get a lot of rain, torrential downpours in a very short amount of time. So cumulonimbus is going to be the one that we're going to highlight, and even though we'll look at some of these, it's the cumulonimbus clouds that we're going to be focusing on when we study severe weather. Last but not least, don't forget to write in nimbus into your notes, because when we find nimbus, you're talking rain or precipitation in some form.